Okay, let's start today's session. First, I will give a small exercise for you all to remember the things we have already learned. The question is, say 3x cube minus 2x square plus 2x minus 3. Need to, this is divided by x minus 1. Okay. This is the dividend and this is the divisor. Okay. Now we have already learned few theories related to polynomials. For dividing polynomials, first we have learned the method long division. The method long division. Then we have learned division algorithm. Division algorithm. Then we have learned the remainder theorem. The remainder theorem. Okay. From long division, we can find both quotient, both the quotient and remainder. And from the division algorithm, also we can find both the quotient and remainder. From the remainder theorem, we can only find the remainder. We cannot find the quotient. Okay. Now your exercise is do this question with all the methods. First, you need to get the answer from the long division. When you use in long division, you can find both quotient and remainder. Afterward, you need to do the same question using division algorithm. Finally, you need to do the same question using remainder theorem. Remainder theorem. From division algorithm also you can find quotient and remainder, but from the remainder theorem, you can only find remainder. Okay. Now start to do this question and send me the answers. From these two measures, you can find quotient as 3x square plus x plus 3. And from this any method, you can find remainder as, you can find the remainder as 0. Remainder is 0 and quotient is 3x square plus x plus 3. Okay. Now I am going to teach another method. This is a shortcut method, but this cannot be used in your A-level exam. You can use this method to get the answer at once or to check your answers. Okay, this method called synthetic division. Synthetic division. It is very easy and very fast method to get the quotient and the remainder. The quotient and remainder. And this can only be used when our divisor is linear polynomial. To use this synthetic division, our divisor should be a linear polynomial. A linear polynomial. That means the degree of divisor should be 1. The degree should be 1. Okay, now I will teach you the method from our question. Here, our question was 3x cube minus 2x square plus 2x minus 3. Need to divide by x minus 1. Okay, first we need to identify the all the coefficients of our given dividend. That means we need to identify the all the coefficient from the given polynomial. That means the coefficient are 3 minus 2 plus 2 and minus 3. This is the first coefficient. This is the second coefficient. This is the third coefficient. This is the fourth coefficient. Okay. Then we put our division symbol like this. Okay. We put our division symbol like this. Afterwards, we set our divisor to 0. That means we need to set our divisor to 0. This is like in the remainder theorem also we set our divisor to 0 and find the value for the variable. When we set our divisor to 0, the value is x equal 1. Then we put this value in here, inside the box. In here we put this value inside a box. Okay. Then now we are going to start our synthetic division. The first thing we need to do is bring down the first coefficient. Bring down the first coefficient. That is, our first coefficient is 3. Simply we bring down the first coefficient. Then we multiply that with the number inside the box. That means 3 need to multiply with 1. Then our value is 3 times 1 is 3. Then we need to pass this value to the next column. That is the column with the next coefficient. That means 3 times 1 need to be passed to here. Need to pass here. Then we add the numbers inside the column. That means 3 minus 2. That means 3 minus 2 is equal to 1. Then we put that number in here. Let me repeat. First, we need to bring down the first coefficient. Then we need to multiply it with the number inside the box. Here the number is getting by set the divisor to 0. Afterward, we need to multiply those two numbers and send the answer to the next column. Need to send the answer to the next column. Then we need to sum up all the numbers inside that column. That means 3 need to add with minus 2. That means 3 minus 2 is 1. Then we need to repeat the same process again and again. That means now here we have number 1. Then we need to multiply it with the number in the box and need to send to the next column. Here 1 is in this column. Now we need to send it to the next column, the answer. That means here 1 need to be multiplied with the inside the number in the box. That means 1 need to be multiplied with 1. Then the answer should be moved to the next column. That means 1 times 1 is 1. We send the answer to the next column. Then we need to sum the values inside that column. That means 2 plus 1 is 3. Here 2 plus 1 is 3. Then again we need to repeat the process. That means we need to multiply 3 with the number inside the box and need to send to the next column. That means 3 times 1 is 3. That means we need to send that answer to the next column. That means 3 times 1 need to send to the next column. Okay. Now we need to add up the values in the same column. That means 3 minus 3 is 0. Okay. Now we already finished our synthetic division. Then the last now we need to take care of the numbers in this row. That means number below the division sign. From these numbers, we separate our last number. We separate our last number. Our last number is 0. Here, our last number is the remainder of this division. This is the remainder. That means our remainder is 0. From all the other numbers, that means 3. Here, first number is 3, second number is 1, and third number is 3. Okay. Now, these are the coefficient of these are the coefficient of quotient. These are the coefficient of quotient. These are the coefficient of quotient. That means after getting those coefficient, that means we get 3, 1 and 3. Then we need to multiply this with x to the power 0, x to the power 1 and x to the power 2. The powers are increasing 1 by 1. Then our final quotient is 3x square plus x plus 3. Now we have already find the quotient and remainder at once. This is very easy method for finding the remainders and quotient. Okay, let me repeat another example for you all, as this is very new method for you all. Let's get our second example as x cube plus 4x square minus 19x plus 3. This is divided by x minus 2. Okay. Now, first thing we need to is identify the coefficient. Here, coefficient of x cube is 1. This is the first number in our dividend. The second coefficient is plus 4. Second one is 4. Third one is negative minus 19. Third one is minus 90. The fourth and the last coefficient is 3. Fourth and the last coefficient is 3. Then we keep our division symbol. Then we need to identify the number that inside our box. For that, we set our divisor to 0. We set our divisor to 0. That means x equal to 2. Now, this is the number belong to the box. Then we put that number. Then we start with our synthetic division by bringing down the first coefficient to the bottom. That means 1. Then we multiply 1 with the number inside the box. That means 1 times 2 is 2. Then we send it to the next column. That is 2. Then we add up the numbers inside the same column. That means 4 plus 2 is 6. Here we put addition. 4 plus 2 is 6. Then we again multiply it with the number inside the box and send the answer to the next row. That means 6 times 2 is 12. Here 6 times 2 is 12. We keep that number into the next column. That means 12. Then we sum up the numbers inside the same column. That means minus 19 plus 12 means minus 7. Then again, we multiply that number with the number inside the box. That means minus 7 times 2 is minus 14. Then we move that number to the next column. That means minus 14. Then we add up the numbers inside the same column. That means plus 3 minus 14. When we sum up those two numbers, we will get minus 11. Afterwards, we allocate our last number in the bottom row as the remainder. Now, this is the remainder. That means our remainder is minus 11. Now, the remaining other numbers we put as our quotient. This is the numbers. This is the coefficient of quotient. That means 1 and 6 and minus 7. These are the coefficient of quotient. That means our final quotient should be made with these numbers. That means we need to multiply with first number x to the power 0, then x to the power 1, and the last number with x to the power 2. That means our final quotient is x square plus 6x minus 7. This is the quotient. And here the number in the last column is the remainder. That means minus 11 is the remainder. Minus 11 is the remainder. Okay. Now I think you can already get the idea about the synthetic division. Okay. First, I will give around 2 minutes to write down those things. Start to write down those things. Okay. Now I will solve the first question. Here our question, the coefficients are 1, minus 2, minus 5, and 6. We need to set our divisor to 0. That means x minus 3 equal to 0. That means x equal to 3. That means 3 is the number inside the box. Number inside the box. Okay. Now we need to bring down the first coefficient, that is 1. Then 1 need to be multiplied with 3. Then we move that to the next column. Then we add up the numbers in the same column. That means 3 minus 2 is 1. Then we multiply again that number with the number inside the box, and the answer will pass to the next column. That means 1 times 3. Here 1 times 3. That means 3. Then we add the numbers inside the same column. Then minus 5 plus 3 is minus 2. Then we multiply minus 2 with the number inside the box. That means minus 2 times 3, and pass that number to the next column. That means here. Then we add up those two numbers. 6 minus 6 is 0. Then the last number in the bottom row is the remainder. Then that means remainder is 0. Then other remaining coefficient are the coefficient of quotient. That means 1 and minus 2. That means our final answer should be minus 2 times x to the power 0, 1 times x to the power 1, 1 times x to the power 2. That means x square plus x minus 2. This is the remainder. Now I will explain another example, but here there is something new to you. Okay. Now our example is 4x to the power 4 plus 3x to the power 3 minus 4x plus 2 need to be divided by x plus 2. Need to be divided by x plus 2. Okay. Now here we can see x to the power 4 is okay. Now x to the power 3 term is also here. But here x to the power 2 term is no. There is no x to the power 2 terms. That means the the coefficient should be 0 here. 0 times x to the power. Because of that, there is no term of x square. In the synthetic division, we need to consider the all the powers. That means when we list the coefficient, we need to include all the terms. If some term is missing, then we need to include 0 for that place. Because we already know 0 times some number is 0. That means first we need to rewrite our dividend. 4x to the power 4 plus 3x to the power 3 plus 0 times x to the power 2, because 0 times x to the power 2 is 0. For synthetic division, we need to consider all the coefficient. If something missing, we need to put 0 for that term. Minus 4x plus 2. Now this is the question for us. Now we can do the similar thing like previous. That means we put 4, 3, 0, minus 4, 2. Then we keep our symbol and put the value inside here by setting the divisor to 0. That means x plus 2, we set x plus 2 to 0. That means x equal minus 2. Then we need to put that inside the box. Then first we need to bring down this number, that means 4. Then 4 need to multiply with minus 2 and send to the next column. That means minus 8. Then we need to add those two numbers. That means 3 minus 8 means minus 5. Then we need to multiply minus 5 with minus 2. That means 10 and send to the next column. Then we need to add up those two numbers. That means 0 plus 10 is 10. Then we need to multiply it with inside the value inside the box. That means minus 2. Then 10 times minus 2 is minus 20, and minus 20 should be passed to the next column. Then we need to add those two numbers. That means minus 24. Then minus 24 need to multiply with the number inside the box. That means minus 24 times minus 2. That means 48. Then we need to send that number to the next column. Then we need to add those two numbers. That means 2 plus 42 is 50. Then the last number in the bottom row is remainder. This is the remainder. And the other number should be our coefficient of quotient. That means 4, minus 5, 10, and minus 24. That means our final remainder should be x to the power 0, second term x to the power 1, x to the power 2, x to the power 3. That means our final quotient should be 4x cubed minus 5x square plus 10x minus 24. This is the quotient. This is the quotient. And our remainder is 50. 50 is the remainder. Okay. Now please write down this example, and then I will give another question for you. Please do that after writing this example. Please do that question and send me the answers. The question is 2 times x to the power 4 plus 3x square minus 5x plus 6 need to divide by x minus 2. Okay. After writing down those things, write this answer, this question, and send me the answers via WhatsApp. The student who already finished this question can write down this question and try. 3x to the power 4 minus 5x square plus 6 is divided by x minus 2. The student who already finished the first one, please write down this question and do the question and send me the answers. While that, I will discuss the previous question. I will give around 30 seconds to write down this question. 3 times x to the power 4 minus 5x square plus 6 is divided by x minus 2. Okay, now I'm going to explain the previous question. This is 2 times x to the power 4 plus 3x square minus 5x plus 6. Okay, in our dividend, we can see the term with x cube is missing. That means there is no term with x cube. Now, before starting our synthetic division, we need to put 0 times x to the power 3 because the term is not there. That means we need to put the coefficient as 0. 3x square minus 5x plus 6 is divided by x minus 2. Now we keep our coefficient 2, 0, 3, minus 5, 0 and put our synthetic division and set our divisor to 0. X minus 2 is 0. That means x equal to 2. We keep that number inside the box. Then we bring down the first number, that is 2. Then multiply it with the number inside the box and move to the next column. That means 2 times 2 is 4. Then we need to add the numbers inside the same column. 0 plus 4 is 4. Then we need to multiply 4 with 2. That means 4 times 2 is 8. Then we need to add those two numbers. That means 3 plus 8 is 11. Then we need to multiply 11 with 2, the number inside the box. That means 11 times 2 is 22. We need to move that number to the next column. Then we need to add up the numbers inside the same column. Minus 5 plus 22 is 70. Then we need to multiply that number with the number inside the box. That means 17 times 2 is 34. Then we need to add those two numbers. That means 6 plus 34 is 40. Okay. Now, this is our remainder, the last number in the last bottom. And other should be the coefficient of quotient. That means 2, 4, 11, and 70. Then we need to multiply those with x to the power 0, x to the power 1, x to the power 2, and x to the power 3. That means our final quotient should be 2x cubed plus 4x square plus 11x plus 70. This is the quotient, final quotient. And our remainder is 40. Okay, write down these things and do the next question. This is this question. Now I am going to solve the second question. Here, first term is 3 times x to the power 4. Now the x to the power 3 term is missing. So we need to include 0 times x to the power 3. Then we have x to the power 2 terms. That means minus 5 times x square. Then our x term also missing. That means we need to include 0 times x. Then plus 6 is divided by x minus 2. Now we already identified all the coefficient. Now we can start our synthetic division. Now we put 3, 0, minus 5, 0, 6. Then we keep a symbol and find the number inside the box. We can find the number by setting the divisor to 0. That means x equal to. Then we bring down the first coefficient 3. Then we multiply it with the number inside the box. That means 3 times 2 and move to that number into the next column. Then we add up those two numbers. From that we can get 6 plus 0 is 6. Then we need to multiply it with the number inside the box. That means 6 times 2, 12, and pass to the next column. That means minus 5 plus 12 is 7. Then we need to consider 7 times 2. That means 14. Then move that number to the next column. That means 0 plus 14 is 14. Then we need to multiply the 14 with 2. That means 28. And pass this number to the next column. Then we need to add those two numbers inside the second column. That means 6 plus 28 is 34. Then from the bottom row, the last number is our remainder. The other numbers are numbers of the quotient. That means 3, 6, 7, 14 are the numbers of quotient. Then we need to multiply with x to the power 0, x to the power 1, x to the power 2, and x to the power 3. Then the final answer to the solution is 3x cubed plus 6x square plus 7x plus 40. This is the quotient. And our remainder is 34. 34 is the remainder. Okay, I will give around 1 minute to write down these things. Our dividend is 7x cubed plus 6 minus 8. First, we need to identify whether there are missing terms. If missing terms, we need to put terms with 0 coefficient. Here, first term is 7 times x to the power 3. Now, x to the power 2 term is missing. Then we need to keep 0 times x to the power 2. Then we need to identify whether the next term is exists or not. Now 6x is already there. Then we put that. Then minus 8. Now this is the dividend we need to put into the synthetic division. Now we gather the coefficient, that means 7, 0, 6, and minus 8 to our synthetic division. Now we are going to start our synthetic division. Now we put 7, 0, 6, minus 8. Then we bring our symbol. Then we need to set our divisor to 0. That means x minus 4 to 0, x equal 4. Then we keep that number inside the box. Then we bring down the first coefficient, that is 7. Then we multiply 7 with 4 and move the final answer to the next column. That means 7 times 4 is 28. Now, after that, we need to sum up those two numbers inside the same column. That means 0 plus 28 is 28. Then we need to multiply 28 with 4. We need to multiply 28 with 4. That means 28 times 4. 28 times 4 is 112. We need to put that number into the next column. Then we need to add up the numbers inside the same column. That means 112 plus 6 is 118. Then we need to multiply 118 with the number inside the column. Now 118 times 4 means 100 times 4 plus 18 times 4. That means 118 is 100 plus 80. Now we need to multiply with 4. That means 4 times 18 plus 4 times 10. 4 times 100. 4 times 100 means 400. 18 plus 4, 18 times 4 is 72. That means the answer is 472. Then we need to move that number to the next column. Then we need to add those two numbers. Then we will get 464. That means this the final number in our bottom row is the remainder. This is the remainder. Other numbers represent the coefficient of quotient. That means 7, 28, 180. That means we need to multiply with x to the power 0, x to the power 1, x to the power 2. That means 7x square plus 28 plus 118 is the quotient. And the remainder is 464. 464 is the remainder. Okay. I will give around 1 minute to write down those things. Okay. Now we write down the process behind the synthetic division. Please write with me. Synthetic division. Step 1. Here first we need to write our coefficient in the dividend. That means the first step should be write with me. Write down the coefficients of the dividend in a row. Make sure the polynomial is in standard form. Open a bracket and write down descending powers of x. any term is missing, if any term is missing, if any term is missing, comma, we must use a zero. We must use a zero. We must use a zero as a placeholder. As a placeholder. For its coefficient. For its coefficient. Now write down step 2. Step 2. Set the divisor equal to set the divisor equal to 0 and solve for x. 0 and solve for x. 0 and solve for x. This value will go in a this value will go in a small box to the left. Small box to the left. Now write down step 3. Step 3. Drop the first coefficient. Drop the first coefficient. Drop the first coefficient straight down below the line. Straight down below the line. This is the first coefficient. This is the first coefficient. the final answer of the final answer. Now write down step 4. Step 4, open the bracket and write down multiply and add. Multiply and add. Under step 4, write down Roman number 1 and start to write. Take the number, take the number we just brought down, we just brought down multiply it by the number, multiply it by the number in the box. In the box. Write the result in the next column. Write the result. Write the result in the next column. Comma under the second coefficient. Under the second coefficient. Put Roman number 2 and write down. Add the two numbers. Add the two numbers in the second column. In the second column and write the sum write the sum below the line. Below the line. Below the line. Now write down step number 5. Step 5. Step 5. Under that, inside the bracket, write down, repeat the multiply and add process. Repeat the multiply and add process. Multiply and add process. Under that, write down, repeat the step 4. Repeat the step 4. Repeat the step 4. Until we have filled. Until we have filled all the columns. All the columns. Write down step 6, step number 6, and open a bracket and write, interpret the result. Interpret the result. And that, put Roman number 1 and write down the remainder. The remainder. And that, write down the very last number. The very last number the very last number in the bottom row. In the bottom row. In the bottom row is the remainder. Is the remainder. Write down Roman number 2 and write down the quotient. The quotient. The other numbers in the bottom row. The other numbers in the bottom row the other numbers in the bottom row are the coefficient of the quotient. Are the coefficient of the quotient. Are the coefficient of the quotient. Okay, up to now, the example we have already done, the divisors are in the form of x minus a. That means when all the divisors are, the coefficient of the x is in the all the divisors are 1. That means when we have used x minus 2, the coefficient of x is 1. That means 1x minus 2. Also, we have used x minus 4. Then the coefficient of x is 1. And we have already used x plus 2. For that also, coefficient is 1. Now, we are going to do an example of the coefficient that is not equal to 1. That means a divisors in the shape of ax plus b. For example, 2x minus 1. In this divisor, the coefficient of x is 2. Now, for these kind of devices, we need to do an extra step, very small extra step. Now, I will explain this process with an example. Let's say we have 20x square plus 60x plus 5. Need to divide by 2x minus 1. The step we are already did is same for this also. The step are very similar to previous one. That means we need to put the coefficient in one row and use our division symbol. Then we need to set our divisor to 0. Divisor to 0. From that we can get x equal half. X equal 1 over 2. Then we inside our box we put half. By setting the divisor 0, we get x equal half. Then we put that number inside the box. Then we do our synthetic division process. Then first we bring down the first coefficient, that is 20, and multiply it with the number inside the box. That means 20 times half means 10. Then we pass that to our next column. Then we add those two numbers. That means 60 plus 10 is 70. Then we multiply back it with the number inside the box. That means 70 times half means 35. Then we put that in the next column. Then we add up those two numbers. 35 plus 5 is 40. Then according to our previous steps, the last number is the remainder. Now this is the remainder. Our remainder is 40. Now according to our previous step, our quotient is 20 and 70. That means 70 to the power x0, 20 to the power x1. That means final quotient is 70x plus 7 plus 70. Okay, now we add a small extra step to this last step when we are finding the quotient. The remainder is exactly same. We do not change it. For the extra step, we need to divide all the coefficient of quotient. Let me repeat. We need to divide all the coefficient of the quotient by the coefficient of the x in our divisor. That means coefficient of x is 2. The extra step is we need to divide all the terms in our quotient by the coefficient of the x term in our divisor. That means we need to divide all the terms with 2 because here the coefficient of x in our divisor is 2. That means This is our leading coefficient. This is our leading coefficient of our divisor. That means in the extra step, we need to divide by the leading coefficient of divisor. This is the extra step we need to follow when we have divisors like ax minus b, ax plus b. That means our final answer should be 10x plus 35. This is the final quotient. All the steps are same as previous, but in the last step, when we are finding the quotient, we need to divide all the terms of the quotient by the leading coefficient of divisor. Okay, first write down those things. Write down those things. I will explain another example and give you some question to try you. 64 times x to the power 3 plus 20x plus 68 need to divide by 2x plus 1. Need to divide by 2x plus 1. Here we have x to the power 3 term. But here x to the power 2 term is missing. So we need to put that term with 0 coefficient. That means 64 x to the power 3 plus 0 x to the power 2 plus 20x plus 68. Then the starting coefficient of our synthetic division is 64, 0, 20 and 68. Then we need to find the value inside the box. That means we need to set our divisor to 0, equal to 0. 2x plus 1 is equal to 0. That means 2x equal to minus 1. That means x equal to minus 1 over 2. That means minus half. Then we need to put down our first coefficient, 64. Then we need to start our division, synthetic division methods. Now 64 need to multiply with minus half. That means the final result is minus 32. We need to keep that in the next column. Then we need to add the numbers inside the same column. That means 0 plus minus 32 means minus 32. Then we need to multiply minus 32 with minus half. That means plus 16. That means plus 16. Then 20 plus 16 means 36. Then we need to multiply 36 with minus half. That means the final result is minus 18. Then we need to add those two numbers. Then 16 minus 18 means plus 50. Then the final value in the bottom row is remainder. This is the remainder. Now the remaining coefficient are coefficient of divisor. Then we need to put x to the power 0, x to the power 1, x to the power 2. But here our leading coefficient of divisor is 2. Leading coefficient of divisor is 2. That means we need to divide all the terms of the final answer by 2. That means the final quotient should be 32 times x to the power 2 minus 16x plus 80. The final remainder should be 50. Final remainder should be 50. Now I will give some question to you all. Try those questions and send me the answers. The first one is 2x cubed plus 3x square minus 4x plus 2 divided by 3x plus 1. The second one is 12 times x to the power 4 minus 6 times x to the power 3 minus 12 times x to the power 2 plus 50x minus 48 need to divided by 2x minus 1. Okay, first write down the example. And then write down the two questions and send me the answers to those two. Okay. Now I will explain the first one. Here 2x cube. Here the coefficient are 2 and 3 and minus 4 and 2. Coefficient are 2, 3, minus 4 and 2. We need to divide by 3x plus 1. That means we need to set our divisor to 0 and find the value. X equal minus 1 over 3. Then we need to put that number inside the box. Then we need to bring down our first coefficient. That means 2. Now we need to multiply it with minus 1 over 3. That means minus 2 over 3. And we put that number inside the second column. Now we need to add those numbers inside the column. 3 minus 2 over 3 means 7 over 3. Now we need to multiply 7 over 3 with the number inside the box. That means minus 7 over 9. Then we need to add up those two numbers. It will give us 9 times 4 is 36. That means minus 43 over 9. Then we need to multiply it with our number inside the box. Then it will give 43 over 27. Now we need to add those two numbers. It will give 2 plus 43 over 27 means 54 plus 43 over 27. That means 54 plus 43 is 97. 97 over 27. Then this is the final remainder. Now these are the coefficient of quotient. Now we need to put our x to the power 0, x to the power 1, x to the power 2. But here our coefficient, the leading coefficient of the device is 3. That means we need to divide all the terms with 3. That means our final answer should be 2 over 3x square plus 7 over 9x minus 43 over 27. This is the final answer for the quotient. Okay. Now I will do the second one also. 12 x to the power 4 minus 6x cube minus 12x square plus 50x minus 48. Need to divide by 2x minus 1. That means our coefficient are, there are no missing terms. Therefore, our coefficient should be 12 minus 6 minus 12 50 minus 48. Then our number we need to find our number inside the bracket by setting the divisor to 0. That means we get x equal half. Then we need to put this number inside the box. Now we start our synthetic division by bringing down this term. Then 12 times half means 6. Then minus 6 plus 6 is 0. Then 0 times half is 0. Then minus 12 plus 0 is minus 12. Then minus 12 times half is minus 6. Then we need to pass that value to next column. Then 50 plus minus 6 is 44. Then we need to multiply 44 with the number inside the bracket in the box. That means half. 44 times half means 22. We need to put that number in the next column. Then minus 48 plus 22 is minus 26. Now we need to keep those numbers in the last row. Then minus 26 is the remainder, and other coefficient are the coefficient of quotient. That means 12, 0, minus 12, and 44. That means x to the power 0, x to the power 1, x to the power 2, x to the power 3. Since our leading coefficient of the divisor is 2, we need to divide every term in the quotient by 2. 0, 2, minus 12 over 2, 44 over 2. That means the final answer for the quotient should be 6x cubed minus 6x plus 22. This is the final quotient. And final remainder is minus 26. I will give 1 minute to write down those things. Okay. Now we are going to do a small activity. Now we are going to factorize x minus 8. X minus 8. Now we already know how to factorize this from our foundations. That means this is equal to x cube minus 2 cube. These are difference of 2 cubes. Difference of 2 cubes. We already know how to factorize difference of 2 cubes. That means we put x and 2 here. Then for getting x cube, we need x quarter. To get minus 2 cube, we need 2 to the power 2. By multiplying these two numbers, we will get x cube. By multiplying these two numbers, we will get 2 to the power 3. After that, we put multiplication of these two numbers, x and 2, inside the middle term as a middle term. That means 2 times x. Then we use our SOAP method. That means same sign. Here minus sign, same as here. Then opposite sign. Here my sign is minus, then we put the opposite sign. That means plus. Then we use always positive sign. That means last term should be always positive. That means the factorization of x cube minus 8 is x minus 2 times x square plus 2x plus 4. Okay. These are the factors of x cube minus 2. That means x minus 2 and x square plus 2x plus 4 are the factors of x cube minus 8. Okay. Okay. Try to write down up to here. I will give around 1 minute. This is a small activity we have done. Now, using this activity, we are going to learn a new theorem. First, write down those things. Okay. Now, I will give another question. Now, we are going to divide our expression x cube minus 8 by those two factors separately. Now, your first question is find the remainder, find the remainder when x cube minus 8 is divided by x minus 2. Here, since we in the question, since they have only mentioned the remainder, try to solve this question by remainder theorem. Remainder theorem. The second question is similar to first one. Find the remainder. Find the remainder when x cube minus 8, x cube minus 8, x cube minus 8 is divided by x square plus 2x plus 4. That means our second factor. This is our first factor. This is our second factor. Now you need to find the remainders when we divide our polynomial by the first factor and the second factor separately. Okay. Write down those two questions and send me the answers. You need to find the remainders when we are dividing with the factor. Okay, start to doing those questions and send me the answers. Okay. All the students get the correct answers. For the first one, the remainder is 0. For the first one, the remainder is 0. For the second one, also remainder is 0. Now let's try another example. Now let's say we have a polynomial x square plus 5x plus 6. Now you all already know the factors of this x plus 2 and x plus 3. Now let's divide x square plus 5x plus 6 with the one of this factor. That means x plus 2. since this is a linear polynomial, we can use remainder theorem. We can use remainder theorem to find the remainder. To find the remainder. That means we need to set this x plus 2 to equal to 0. That means x equal minus 2. Then we need to substitute that value to the variable of our dividend. That means when we divide by x plus 2, the remainder is f minus 2. That means minus 2 whole square plus 5 times minus 2 plus 6. That means 4 minus 10 plus 6. The final answer is 0. Likewise, if we divide by the other factor, that means divided by x plus 3, the other factor is x plus 3. Then our remainder should be f minus 3, because we need to set the x plus 3 equal to 0. That means x equal to minus 3. Then we need to put that value to the function. Then the final remainder should be minus 3 whole square plus 5 times minus 3 plus 6. Then minus 3 whole square is 9. Minus plus 5 times minus 3 is minus 15 plus 6. That means final answer also 0. Now we can see a pattern by observing those results. In here, when we divided by a factor, our polynomial is divided by a factor, the remainder is 0. In here also, when we divide by a factor, the remainder is 0. On the other examples also, when we divided by a factor, the remainder is 0. On the other factor, if we divide by the other factor also, the final answer is 0. Okay, from those observations, we can say if we divide a polynomial by its factors, the remainder should be 0. Let me repeat. If we divide a polynomial by its factor, the remainder should be 0. That means when a polynomial is divided by one of its factors, the remainder should be 0. The remainder is 0. Okay. Please write down these things with the example of fx equal to x square plus 5x plus 6. This is very important thing we have observed by looking the final outcome of each examples. That means if we divided by a factor, then the remainder should be 0. Then the remainder should be 0. Okay, first write down those things. Okay, now by using this outcome, we are going to learn our next theorem, that is factor theorem. That is factor theorem. Under factor theorem, they have mentioned that this is the factor theorem. First write down factor theorem. First write down the topic factor theorem. Under that, write down if x minus a, if x minus a, if x minus a is a factor of, is a factor of, is a factor of is a factor of fx, factor of fx, comma, then fa equal to 0. fa equal to 0, where a is a real constant, where a is a real constant. This is the factor theorem. That means if x minus a is a factor of fx, then fa should be 0. fa should be 0. Just write down this. That means if x minus a is a factor, if x minus a is a factor, then we can say fa is equal to 0. This is the summary of factor theorem. If x minus a is a factor, then fa should be 0. That means we simply set our factor to 0. From this, we can say x equal to a. Then we put that value inside our function. This is very similar to the remainder theorem. Here, we know that if we divided by x minus a, the remainder should be fa. Since this is a factor, the remainder is 0. This is a one-off form of remainder theorem. Let me repeat an example. Let's say we already know x square plus 5x plus 6. The factors are x plus 2 and x plus 3. According to our factor theorem, according to factor theorem, if x plus 2 is a factor, that means f minus 2. That means we set our factor to 0. From that, we can obtain x equal minus 2. Then if we plug that value to function, then this should be 0 according to the factor theorem. That means if x plus 2 is a factor, then f minus 2 need to be equal to 0. We have already found that f minus 2 is 0 in our previous example. This is the brief idea of the remainder theorem. That means if x minus a is a factor, then fa is equal to 0. This is the summary of the remainder theorem. So summary of the factor theorem. Okay. Please write down these things. I will give around 1 minute to write down these things. Now, according to factor theorem, if x minus a is a factor, then fa is equal to 0. Okay. Now, we are going to learn another theorem, the same as the factor theorem, the converse of the factor theorem. Our next topic is the converse, the converse of factor theorem, the converse of factor theorem, the converse of factor theorem. This is similar to factor theorem, the other way around of the factor theorem. Now, write down this with me. If fa equal to 0, if fa equal to 0, if fa equal to 0, then x minus a is a factor of fx, is a factor of fx. Now this is similar to factor theorem, but this is now first, if fa 0, then we say x minus a is a factor. This is same as the here from left hand side we obtain our right hand side in our remainder in our factor theorem, but in converse of factor theorem, from the right hand side we are getting left hand side. That means if fa equal to 0, then we say x minus a is a factor of fx, factor of fx. On the factor theorem, we go from left hand side to right hand side, but in the converse of factor theorem, we are coming back right hand side to the left hand side. First, I will, if you cannot understand this, first I will give some example for this. Now, in our converse of factor theorem set, now let's say we have fx equal to x square plus 5x plus 2. Now let's consider x equal minus 2 case. That means let's consider f minus 2. From x minus 2, if we substitute minus 2 to the variable, 6, we get 4 minus 10 plus 6, that is 0. Now we have obtained f minus 2 is equal to 0. That means we have obtained our left hand side. Then according to converse of factor theorem, we can say if f minus 2 is 0, then we say x minus 2. Here, if inside the bracket a, then we put x minus a. That means x minus 2 should be a factor of fx. That means x plus 2 should be factor of fx. In the factor theorem, we say if x minus a is a factor, then f is 0. The other way around, we are saying in our factor theorem. In the converse of factor theorem, we say the other way around. That means if f minus 2 is 0, then x minus 2 should be our factor. That means x plus 2 should be our factor. Okay, please write down this example also. But in mathematics, we cannot go both way like this in every examples. But in here, we can move from left hand side to right hand side, and from right hand side also we can move to the left hand side. After writing down those things, I will give an example that you cannot go onto both sides. I will give an example after writing this. First, try to write down those things. I will get around 1 minute. Okay, now I will give an example that we cannot go for both sides. In this example, in our factor theorem, we can move from left hand side to right hand side. And also someone can move from right hand side to left hand side. That means if x minus a is a factor, then fa is equal to 0. On the other way around, if fa equal to 0, then we can say x minus a is a factor. But now I will give an example that cannot go in on the both sides. Let's say x equal 1. X equal 1. If x equal 1, we can say x square is also equal to 1. Let me repeat. If x equal 1, we can say x square equal to 1. Now let's consider, can we go from right hand side to left hand side? That means if x square is equal to 1, then someone can say x equal 1. Let me repeat. Now we can go from left hand side to right hand side, because if x equal 1, then we can confidently say x square is equal to 1. Now if x square is equal to 1, can we say x equal 1? Confidently, can we say x square 1? Let's check that. Now if x square is equal to 1, now we can factorize this. That means x square minus 1 equal to 0. When we move 1 to left hand side, then x square minus 1 is equal to 0. That means x minus 1 times x plus 1 is equal to 0. Then, according to our knowledge on solving equation, for become this one 0, either x minus 1 should be 0 or x plus 1 should be 0. That means x minus 1 equals 0 or x plus 1 need to be equal to 0. From first, we can say x equal 1 or x equal minus 1. That means if we are in right hand side, that means x square equal to 1, then we cannot exactly say x equal 1. The only thing we can say is x equal 1 or x equal minus 1. Let me repeat. From right hand side, we cannot exactly say x equal 1 because from x square equal to 1, the final answer should be x equal 1 or x equal 1 or x equal minus 1. That means we can go from left hand side to right hand side, but we cannot come from right hand side to left hand side. This is a very good example that we cannot say both theorem and converse always true. This is an example for that means we cannot say everyone can go both sides. But in factor theorem, we can go both sides. That means factor theorem also true and its converse also true. Let me repeat. Both factor theorem and its converse is true. That means if someone say x minus a is a factor, then we can say fa equal to 0. Or if someone say fa is equal to 0, then we can say x minus a is a factor of fx. Okay, write down this example. This is very good example that we cannot go both sides. There are so many examples like that. Now we are going to solve some question using factor theorem and its converse. That means converse of factor theorem and factor theorem. It's first we will discuss an example. So that x minus 1 is a factor of fx equal x to the power 2 2027 minus 15x plus 14. Now we need to show that x minus 1 is a factor of this function. That means if we divided by x minus 1, the remainder should be 0. According to remainder theorem, remainder should be 0. And according to the factor theorem, we need to set x minus 1 equal to 0. That means from that, we will get x equal 1. Then we need to find f1. Then if f1 is equal to 0, then we can say x minus 1 should be a factor of, this is factor of the given function. That means we need simply Here factor is x minus 1. We need to set this value to this factor is to 0. From that we will get x equal 1. Then we need to substitute that value to the function and check whether it is 0 or not. If 0, then it should be factor. If it is not equal to 0, then it is not a factor. Now, when we consider f1, we will get 1 to the power 2027 minus 15 times 1 plus 14. That means 1 minus 15 plus 14. That means 0. Now, we get f1 equals 0. Now, we can say, therefore, x minus 1 should be a factor of the given function. Okay. I will give around 1 minute to write down this. Start to write down this. Now, I will explain another example. Example 2. Show that x plus 3 is a factor of fx equal x to the power 4 plus 29x plus 60 plus 6. Okay. Now we need to check whether x plus 3 is factor or not. That means we need to set the factor equal to 0. Then we can observe x equal to minus 3. Then we need to check our value, our function value when x equal to minus 3. Then our function value is minus 3 times 3 to the power 4 plus 29 minus 3 plus 6. Minus 3 to the power 4 is 81. 29 times minus 3 is minus 87 plus 6. From 81 and 6 we can get 81 plus 6 is 87. Then from 87 minus 87 the final answer would be 0. Then since our f minus 3 is equal to 0, then we can say x minus minus 3 should be a factor. That means x plus 3 is a factor of the given function. Okay, write down this one, and now I will give a question to you all. Try this question and send me the answers. Show that first write down the example, then write down this question and send me the answers. Show that x plus k is a factor of fx equal x cube plus 4k. So I write down this one. And factor of fx equal x cube plus 4k x square plus 4k square x plus k cube. Okay. After writing example 2, write down this question and send me the answers via WhatsApp. Here we need to show that x plus k is a factor. That means first we set our factor to 0. That means x equal minus k. X equal minus k. Then we need to find the function value when x equal to minus k. Then minus k cube plus 4k times minus k square plus 4k square times minus k plus k cube. Minus k cube means minus times k cube plus 4k times minus k square means plus k square. Then 4k square times minus k means minus 4k cube plus k cube. Then final value is minus k cube plus 4k cube minus 4k cube plus k cube. Then these two add up to 0 and these two add up to 0. Then the final answer is 0. Therefore, if minus k is equal to 0, then from that we can say x plus k is a factor of this function. Okay. Now I will give another two questions. Please do those questions and send me the answers. First one is fx equal x cube plus 5x square plus ax plus b has factors x plus 1 and x plus 2. Factors has factors x plus 1 and x plus 2. Find the values of a and b. A and b. This is the first question. Now I will give the second question. Write down those two questions and send me the answers via WhatsApp. Second question is let gx equal to 4x cube plus px plus q given that 2x minus 1 is fact of gx and that when gx is divided by x minus 1, the remainder is 10. The remainder is 10. Find the values of p and q. Okay, write down those two questions and send me the answers via WhatsApp. Okay, now I will do the first question. Here they have mentioned that x plus 1 is remained, x plus 1 is factor and x plus 2 also factor. That means if x plus 1 is factor, then we can say f minus 1 should be 0. That means we set x plus 1 equal to 0. From that, we obtain x equal minus 1. Then we find the function value. Then function value should be equal to 0. Similarly, if x plus 2 is a factor, then f minus 2 should be also equal to 0. Now we have two equations. That means f minus 1 equal to 0. That means minus 1 cube plus 5 times minus 1 square plus a times minus 1 plus b equal to 0. From that we can obtain minus 1 plus 5 minus a plus b equal to 0. From that minus a plus b, here minus 1 time plus 5 means 4 equal to 0. That means 4 is equal to b minus b plus a. That means we keep 4 in left hand side and move these two variables onto right hand side. That means 4 is equal to a minus b. This is our first equation. Now since f minus 2 also becomes 0, we can say minus 2 cube plus 5 times minus 2 square plus a times minus 2 plus b also should be equal to 0. That means minus 8 plus 20 minus 2a plus b also equal to 0. That means from these two we can say 12 minus 2a plus b equal to 0. That means 12 is equal to 2a minus b. This is our second equation. From subtracting second equation 2 minus 1, we get on the left hand side we get 12 minus 4. On the right hand side b will cancel out and we will get 2a minus a. That means 8 is equal to a. From the first equation we have obtained 4 is equal to a minus b. That means 4 is equal to 8 minus b. From this we can substitute a equal to 8. Then we can say 4 minus 8 equal to minus b. That means minus 4 is equal to minus b. That means b is equal to 4. Final answer should be a is equal to 8 and b is equal to 4. Okay. Write down those things if you were unable to find the answers, and then try the second one. Okay, now I am going to solve the second one. Here they have mentioned that 2x minus 1 is a factor. That means we need to set this to 0. From that, we can get x equal half. That means if this is a factor, g half should be equal to 0. That means g half is equal to 4 times half to the power 3 plus p times half plus q need to equal to 0. That means 4 over 8 plus p over 2 plus q is equal to 0. That means 1 over 2 plus p over 2 plus q is equal to 0. That means p over 2 plus q is equal to minus half. This is our first equation. Also, they have mentioned that x minus 1, when we divide by x minus 1, the remainder is 0. Remainder is 10. That means, according to our remainder theorem, g1 should be equal to 10. g1 should be equal to 10. That means g1, according to remainder theorem, g1 is equal to 10. That means 4 times 1 to the power 3 plus p times 1 plus q should be equal to 0. So equal to 10. Remainder is 10 equal to 10. That means 4 plus p plus q should be equal to 10. From that we will get p plus q is equal to 6. This is our second equation. Now we can subtract second equation from 1. From that, q term will cancel out and we will get on the left hand side p minus p over 2. On the right hand side we will get 6 minus half. That means p over 2 is equal to 6 plus 1 over 2. That means p over 2 is equal to 13 over 2. Then we can cancel out 2. That means p is equal to 30. From the second equation, we will get p plus q is equal to 6. That means 13 plus q is equal to 6. That means q is equal to 6 minus 30. That means minus 7. Okay. Now I will give around another 2 minutes to write down those things if you are unable to solve the question.